Hello everyone, welcome back to another video. So today we will discuss solutions for weekly contest 378, and I was able to solve first three questions. So we will see the solutions of first three questions only. So first question is, check if Bitwise or has a trailing zero. So in this question we are given an vector of positive integers named as nums, and we have to return true if it is possible to select two or more elements in the array such that bitwise or of selected elements has at least one trailing zero in its binary representation. For example, let's say I take a number as 5 and other number as 4. So 5 doesn't have any trailing zeros because digit last digit in binary representation is 1, as in binary representation of 4 last digit is 0 and has two trailing zeros. Means trailing zeros basically means number of zeros from right side, so it should be at least 1. So let's see the first test case. We are given 1 2 3 4 5, and if we select 2 and 4 element and take their bitwise of 2 and 4 is 6, and its binary representation is 110, and it has one trailing zero, so we can return true. In last test case 13579, there is no possible way to select any element, two or more elements, such that it has no trailing zeros. It has at least one trailing zero, so the answer here is false. Now let's try to know all the properties of or. 0 and or 0 is always 0, and 1 or 0, 0 or 1, and 1 or 1 is always equal to 1. So these are the basically four observations in bitwise over. Now we want last bit in the or should be equal to 0. So we don't care anything might be before it, 11010, any pattern of 01 works before it, but just last digit in binary representation of bitwise or should be 0. Now when this can happen, when we take XOR of elements which have 0 in its which has 0 at last digit in its binary representation, and such numbers which has 0 in its last digit in its binary representation are basically even numbers, because this adds 2 raised to power 0, which is 1, and all the elements left to it are even. So this element is responsible for this digit is responsible for making the number even or odd. So if we get at least two elements which are even in the array, we can say we can return true, or else we have to return false. So basically a simple implementation problem. So I declared a counter, and for I will iterate true for loop, and if nums of I mod 2 is equal to 0, I will just increment the counter and return if. So this is basically, it will return if true if counter is greater than equal to 2, or else it will return false. So this was first question. I guess it was pretty easy as a lot of people solved it. Now second and third question, so both are same question, just differences between constraints. So in second question, the length of string is less than equal to 50, whereas in third question the length of string is 5 into 10 raised to power 5. Now what we have to do in this question is we have to return the size of a substring, maximum size of substring, such that it occurs at least thrice and it only contains single character. So let's take this example A. So substring A is occurring thrice, once here, and again here. And also this substring is special because it has only one character, so maximum possible such substring is of length 2. The answer of the first test case here is 2. Now similarly, in this A, B, C, D, F, in this question there is no such substring which occurs at least 3 times, so we have to return -1. And in last test case, A, B, C, A, B, A, so here substring A occurs thrice, and we can it is the answer here is 1 because length of the substring is 1, and there is no other substring which has bigger length than this. So how to do this? So in second question the constraints are very less, so you can just check all the substrings from I to J and take its occurrence. So I think it will be like n raised to power 4 kind of solution, and it will probably work. I didn't wrote brute force for it. I just solved third question first and just submitted if same solution for second also. So you can check its brute force, but it should be n raised to power 4 only. So I and J to iterate to for all sub to take one substring from the string, and let's say k2, uh, again I use k and k2 variable to check the occurrence of each substring. Now you can do this in using sliding window also, so n cube might also be is also a possible solution. So this is the brute force, but we don't want brute force. We want some linear type of solution, because here in third question the constraints are 5 into 10 raised to power 5. So let's try to analyze try to come up with some observations. Now let's say we in this type of questions always remember that the solution, we have to check the existence of solution for each character in alphabet, like A to Z. So the longest substring might have A, B, C, D, or any character from A to Z. So we have to check all the maximum substring which we can find by each character. And let's say we fix a character. Let's say it is A. Now I have a let's say I have a substring, continuous substring of length A, of length 5, and this is the only substring of length of character A, and it has length 5. So can I form this type, can I say that there is a longest special substring which occurs thrice? Yes, it can be 3 times A. So first substring can be this, second can be this, and third can be this. So the length of such special substring is 3. So if I have characters which are repeating x times, x is here variable, integer variable which represents just the consecutive occurrence of character A, and let's say it is x. So I can always create 3 substrings of x minus 2 length, because let's say I have 4 characters. First 2 will become can make one string, second 2 can make another substring, and third, from starting from third, can also make another substring. So this is first observation, that if we have we have to store maximum continuous substring of each character from A to Z. and we can always make x minus 2 longest special substring, but there is also a condition that x should be greater than equal to 3, because x is equal to 2 we cannot make 3 special substring, so x should be always greater than equal to 3 itself. Now second observation is, if there are two such substrings, let's say I have 4 A's and there was some break between them, so that means there are 4 occurrences of A, again some other string, other substring, and there is again 3 occurrences of A. Now here I can make longest substring of length 3, because 1 will be satisfied here and 2 occurrences of length 3 will be satisfied in here itself. So in this case we can make 3 length maximum length as 3. Now let's just take another case of this. If I say A B C and then I have 2 A's, now here we cannot make length 3, because this will contribute to substrings, but only 2 substrings of length 3 are satisfied, and this cannot satisfy another substring of length 3. So here we can maximum what we can make is 2, but we don't need to consider this because this will itself make length 2. So this is second observation. So we have to store first maximum occurrence of substring, which first maximum length of substring, then we can also we have to store second maximum length of substring, and third might be that let's say this is second observation. Now I have A, then again B, then again 4A, then C, and then again 4A. So here there are just basically this is very clear that there are 3 substrings of length 4, and each substring has character A, single character in it. So here answer is 4. So these are the only 3 observations, means 3 test cases we have to check and find the maximum answer in it. So we only need to store 3 maximum substrings, 3 maximum substrings created which can be formed, which are present in the string of each character from A to Z. So we have to store that. Now how can we store that? So there's a simple technique. You can also use a vector, but I thought it will give me TLE or something, but I have seen other solutions, so it basically works. But this technique is also I have used many times on code forces, so I think it is important. Let's say I have initialized 3 vector MP, MP2, MP3. MP is for maximum, MP2 is for second maximum, and MP3 is for third maximum. Now let's say I get the continuous segment, continuous substring of length 4 for A. Then I will store MP of A as 4. Now again I get, let's say, 3. Now I will check that MP of I is already filled, and if it has greater value than current value, if it is greater than current value, I will not put it here, but I will put 3 over here because this is empty. Now again if I get, let's say, a substring of length 2 of A, which at then again I will check it. I will first compare it with 4. If it is greater, then I will put it here, and if it is not, I will just ignore. Again I will compare it with 3, and if as 2 is less than 3, I will ignore it and put it here. Now let's say I get for B I get a substring initially I get a first I get a substring of length 3. Then again in the later after getting 3 substring, again I get different character, and again I get a substring of length 4. But here if you compare 3 with 4, 4 is greater than 3, so maximum substring till now should be 4. Now I will remove this 3 and put 4 here, but I will also shift this 3 to next maximum. So this is the technique, uh, not technique but simple implementation, which is I which I have solved many questions using this. Now again, if I get, let's say, 3 substring, now I will compare it with mp2, as now it is greater than equal to 3. I will make this 3 equal to 3, this I will shift this 3 to next, and put this 3 here. Now again, let's say I have an example like this. I have found 2 substring and 1, and I get another current substring of length 3. Then I will remove this 2, put 3 here. I will remove this one, put 2 here, and this one will shift here. So this is basically a small technique which is useful to store only 3 maximums, and first we store first maximum, second maximum, third maximum. So let me just show you the code. So I have declared 3 maps, and I have initialized the current counter as 1 and current character C as s of 0, and I just took n as length of string, and I will iterate from 1 to n, and if s of I equal to C, I will just increment counter, current counter, and if it is not equal to 0, not equal, so if the first maximum itself is not initialized or 0, I will put the current counter in it, and if it is already has been initialized, I will just compare it with first maximum, and if it is greater than equal to current is greater than equal to first maximum, I will shift each maximum to right side and make current maximum as first maximum as current. Again, if current is greater than equal to mp2, means second maximum, I will shift second maximum to third maximum and make second maximum equal to current, and else I will just take maximum of mp3. I will just compare current with third maximum, and if it is greater than it will just save that current into mp3, and I will just update the current character and also current counter. And at the end of for loop also, we have to check the current, and because after updating at last character, there is an edge case which we have to also consider. Now I will iterate from 0 to 26, and now if all the maximums are equal, like this condition, here I have written all fours are equal. All there are four occurrences of three occurrences of four characters here, so answer here can be 4. So I will just take max of mp of I, and also we have to check if mp of I is greater than 0, because there is a possibility that all the maps are not initialized at a single character, and so all the values are 0, and if it is compared here, it will take max as 0, which will not satisfy the -1 condition. Now second condition is when first maximum and second maximum are equal. uh, so let's say I have two strings of length 5 5. I found them, so I can make substring of length 4, because from 5 I can take two substrings of length 4, and from 5 again I can take two substrings, so 2 plus 2 4, which is greater than equal to 3. So I can take MP of I minus 1, so 5 minus 1. And another condition is when the absolute difference of in between first maximum and second maximum is 1, I can make, let's say, 5 and 4. So this will contribute 4 twice and this will contribute 4 once. So we got 4 thrice and it satisfies our condition. So I will just take answer max to mp2 of I. Also need to consider mp of I greater than equal to mp2 of I greater than equal to 1. So if you just write these cases, and you will see why I am doing this, because let's say I take when first maximum and second maximum are equal, and let's say the substrings have length 1 1. We cannot make 3 substrings, but if the substrings are of length 2, this will make 2 substrings of length 1 and this will make again 2 substrings of length 1. So one is not will substring of length 1 will not satisfy 3 occurrences. Similarly, in second test case, if mp2 of I is 0, it will not contribute a single substring. And also if the substring itself is greater than equal to 3, it can contribute mp of I minus 2 uh, substrings of length 3 of length mp of I minus 2. And yeah, that's it. That's the solution. So you have to just take some conditions and some observations, and also some people some other, if I say I have to show some other solutions. So a lot of people also used just a vector of map of vector, and this is also doable, but I thought this will give TLE, but this is little bit complex. But if you understand this technique or how this works, so you will understand this solution also. I also tried to solve D, but I wasn't unable. This was harder than normal because it also had 7 points and only 100 people were able to solve it. So if I solve it, I will try to make a tutorial of it. But if I don't, because I probably don't know the topic which is required here, so I will try to upsolve. And thank you for watching the video.